So we're here to solve this Kurotto hex puzzle by Takeya Saikachi, themed around 5 rings and themed around presumably the Tokyo Olympics, so we hope go off safely in the coming months. We're going to work our way through each of these individual rings, but then find the interlocking logic to get us to the one solution. I'm going to start on the upper left where we've got all the digits 1 through 6 around this ring, but we've got a very big digit near some smaller digits. One thing you'll notice is what that means is that a key cell to shade is this one, and in shading that we actually have to dodge the ones around it. If I shaded this, I'd actually complete a group of size 2, and the 6 can never get larger than 2. If I shaded this, we'd have a group of size 3. At least 3 is seeing all the cells the 6 is seeing. And so where you have to have cells that the 5 or 6 see that the small digits around them don't see, the same logic that the 6 doesn't have this upper or lower cell is why the 5 doesn't have these cells marked. That means that the 2 will always take at least 1 cell here. This 6 group has to take at least 5 cells through this space. We've got 3, 4, 5. That marks this off. Means this 3 always takes this cell. Notice the 3 is now actually seeing all of the cells the 4 connects with because these are now adjacent except for this cell. So if the 4 sees one more space in total, it's got to shade this cell. That's going to complete the 1 clue and mark these off. In doing that, we now actually have marked that the center cell is not taken by these groups, and so this group of size 6 has to have not just 5 outside, it has to have 6 outside, which puts this in, puts this in. I think this seed is a good start for the upper left of the puzzle. Coming to the center ring, same sort of thinking. Again, this bigger number has to dodge the smaller numbers near it. If these connected again, now the 8 and 6 are seeing all of the same cells, and so they can't be of different sizes. So this is a pattern here. This is a pattern here, and then even around these cells where this 6 sees these 2 alongside the 5, it's got to be one larger, so it's got to see this cell but not share it with the 5. This 6 sees that cell, doesn't share with the 5, and so we get this pattern of on, off, effectively around this ring to get the right shape. And similar stuff in the upper right. This 21 isn't close in size to the 1 or 6, so it doesn't want to see those. This 6 needs to see a cell that the 5 doesn't to get as large as 6, and so this has to come in but not share a cell to the right. This 5 needs to see cells that the 3 doesn't see to get larger than the 3, so it sees this but doesn't take this. And I think there's even a case for this 4 to work. It's got to see some cells that the 3 does not. And you've got some options here, but as we shade in impossibilities or sort of eliminate some of the possibilities, we'll figure out how that goes. Here's the first place I'm going to let the rings try to interlock. So this group coming out from here is 5 or 6 large, and this group coming from the 21 is 20 or 20 large. And these have to dodge, so one will come up and one will come down. But this group of 20 or larger is not going to get into the space and be able to fill, so it's got to come down. And we still don't have a ton of room, but this group that's 5 or 6 in size is coming up, and it's not joining to this group that's 7 or 8 in size. As it fills into here, this group that's on the other side also coming of 5 or 6 in size has to join with it. They can't both grow to be 5 or 6 and not come together, so this is a forced connection, and that will help us a little bit through the next stage of the puzzle. In part, it now actually limits this 7 or 8 size group to come over in this way. That means that this 1 must take the interior cell, which means that we've now actually fulfilled the 6, and we use an interior cell over here. This interior means that now we have a group of size 2 and a group of size 3 coming out from this space, and it means we need to have 4 cells coming from this 5. So we have this marked in, and that all looks good. We don't have as much to do with the lower right ring, but as we keep going around the grid, let's look at the lower left ring. This has a group of size 20 that's got to dodge the 5s just around it, so same logic as every other ring we've looked at. This group of size 5 has to take this cell, but isn't going to connect up to see the cell that joins to the 1. And so now we have a group of size 19 or 20 coming from the cell, and it's got to continue to grow, but it can't collide with this group, so it's going to have to form a channel moving out here. This 5 needs to take the cell to keep growing. We're now in a space where we can see, is there a way to kind of come through the center here and keep growing larger? And that's going to cause an issue with this group right here that can't grow more than now size 2. So a key constraint in this grid is that this 20 needs to keep growing, but it can't grow through the center channel. You can't come and take these cells near the 5. And once that's marked off, a cell like this is a pinch point that would leave everything else from progress. So the 20 must come along the bottom row. And in doing so, it puts a fair amount of limitation in the grid. It actually puts all these cells in. And so let's actually do a kind of maximum count of what we can take. We can take these 2, this is a third, this is 13, 14, 15, 16 coming up. It means the 1 always is a center cell. It means the 2 is taking this last cell. So we still have a total of 16, 17, 18, 19, 20 through to here. If this 4 needs to take 3 cells and this take 2 cells, that's going to force this. So we still now have a total of 17, 18, 19. This is 20. And that's if we took all of these cells that are still available, these 3 extra in white and the 17 we've marked. Now we have a case of asking, does this 20 coming from here, is it the same group as this big 20? And you can quickly sort of think about if it was a different group, you'd have to come like this, again dodging the cell, and you'd pinch off here. So the way the logic goes is these are the same big number, and they've connected this 21 and this 20 connect. It's a 20 large group. We've got 20 cells marked, and there's a single 1 in the center of this ring that gets the difference in size to work out. So that's put a whole lot in the grid, and it's also now given us this constraint that the center cell isn't taken, so we can come back to this corner where we need to now take 5 cells from the shaded group, and we already made this great progress in the upper left ring, so we only have 5 cells we can reach that we can take. So we put those in. This 3 has to take the cells I've just marked. That leaves 1 cell for this one group, so these are all now fulfilled. The 6 we need to take here has just 1 option for it, so got that set. As we now come into the center, we have a group of size 5 and a group of size 4, and they have to dodge each other because they're different sizes. So as they keep growing up, and they'll have to take at least 1 of these cells. This will also have to take at least 1 of these cells. These will now also cause some issues with the groups coming from above. So coming from this, where we have 1 already taken, this is going to also be a group of size 5, but it's too far away to be the same group of size 5. And so it could take 1, 2, 3, 4 cells, but it can't take this 5th cell. It would collide with what's in blue. So it must take this cell. And taking this cell, you'll actually see it can't further take another cell down here. We've actually now marked this cell as unusable. And so this group of size 5 can only take the 5 cells I just marked. And that means this can only take the 5 cells left for it. So those are very constrained spaces. There's going to be a group of size 4 from these, and it will take 1 of these cells, but that will eliminate this option. That now puts in this group of 4 and 4, so these all look good. We've now got to finish out the grid by getting a group of size 7, potentially distinct from this group of size 7, but there's not enough room. There are only 6 open cells here to take, so these are the same group of size 7, and this is the only efficient packing for that. That leaves behind 5 and 2 cells for the final groups, and we finished this fun Kurotto puzzle, which really did take a whole travel around each of the rings and find the interlocking logic, including how this 20 and 21 connect to get through the end. So I hope you got a sense of how to visualize different parts of the solve, and we'll see you again soon.